This is the answer key to the polynomials study guide for Algebra 1. More polynomials than the exponents. So we're talking about what a polynomial is. Question number 1 asks us to determine if they are monomials, and if they are monomial, please tell us the degree of the monomial. In order to be a monomial, you can't have exponents that are variables, and then when you do have exponents, they can't be negative, which these would both be negative, so that's not a monomial. And they can't be fractional, so that's not a monomial. They can be whole numbers like this. This is an example of a monomial. Now to find the degree of the monomial, you add up the exponents of the variables. It's 2 plus 3 is 5 plus 4 is 9. So the degree of this monomial equals 9. Notice that it's a monomial, mono 1, because it's one term. This is a polynomial. Now there's 4 terms in this polynomial, 1, 2, 3, 4. To determine the degree of this polynomial, we determine the degree of each monomial, each term, if you will. So this one was 9, because we add up the exponents. Here we again do the same thing. This is degree 6, this is degree 2, because 1 plus 1 is 2. This is degree 1, and this is degree 0, because there are no variables. Therefore, we don't continue to add, because exponents follow different rules. We don't add the exponents across a plus sign, we add them when we're multiplying. The degree of this polynomial is 6. It's the highest of all of my options. 3, A, B, and C asks us to add or subtract based on what it's asking you to do. See if I can fit in A down here. I'm just going to combine my like terms. This plus sign really doesn't mean anything. It's just essentially telling me that it's 2 binomials. These are considered like terms. 5a squared plus 18x squared, a squared is 13 a squares, and a negative 3 and a negative 1 combine to make a negative 4. B is adding a trinomial to another trinomial. So really these parentheses don't mean anything. We can use them to separate 2 trinomials, but overall the process is the same. 4m squared plus negative 3m squared is just 1m squared, or m squared. A negative m and a positive 10m is a positive 9m, and a 2 and a 7 combined to make it plus 9. Now C is different because of this subtraction, so we have an extra step. We actually do need to get rid of this these parentheses, because we're subtracting. We're subtracting not just the first term, but we're subtracting all 3 terms. 9b cubed minus 13b squared plus b. A negative negative is a plus 13b squared. A negative negative is a plus 5b. And a negative 14 is a negative 14. By like terms, well, there's no other 9b, there's no other b cubed, so it's 9b cubed. It's a negative 13b squared and a positive 13b squared. So those cancel each other out. They're called additive inverses. I have a b and a 5b, which is 6b, and a constant negative 14. There's a trinomial of degree 3, because there's degree 3, degree 1, degree 0. Trinomial because there's 3 terms, degree 3. There's a trinomial of degree 2, because it's 2, 1, 0, degree 2. And there's a binomial of degree 2, 2 and 0, so it's degree 2. Multiplying polynomials, there are several ways that you can do this. You could use the table method. You could use the double distributive property, or in this case, just a distributive property method. Or you can use the vertical method, which is the traditional algorithm. For this one's pretty easy. I'm just going to distribute whoosh, whoosh, whoosh. X times 2x squared is 2x cubed. X times negative 3x is negative 3x squared. And x times 9 is 9x. There's a trinomial of degree 3. B is also fairly easy, so I'm just going to distribute whoosh, 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 whoosh. Negative 5 times 4 is negative 20. B to the third times b to the fifth is b to the eighth. Remember, exponents follow different rules, so when I'm multiplying, they get added. Negative 5 times negative 2 is a positive 10. B to the third times b to the third is b to the sixth. When I do negative 5b cubed times b, it's negative 5. Then b cubed times b is b to the fourth. Negative 5 times negative 11 is a positive 55. B to the third power. C is where we finally multiply a binomial times a trinomial. So I'm going to use the table method, Punnett square method, you can call it that. There's also the vertical method, but I'm going to do the table method. B, negative 2. Down the side, b squared, negative b, and a 1. You could have switched them, put the 3 up top and the 2 on the side. That's called the commutative property multiplication. That also would work. B squared times b is b cubed. B squared times negative 2 is negative 2b. Negative b times b is negative b squared. Negative b times negative 2 is a positive 2b. 1 times b is b. 1 times negative 2 is negative 2. The like terms tend to be on the diagonal. So these two are like terms, and these two are like terms. They tend to be on diagonal. So let's fully simplify. B cubed is the only of that variety. Negative b squared and negative 2b squared is negative 3b squared. B and a 2b is a 3b and a negative 2 all by itself. This is a 4-term polynomial of degree 3. So that's how I could have done the box method, or the table method. For D, I'm going to show you this. I could have done the double distributive property, which would have whoosh, whoosh, and whoosh, and then I whoosh, whoosh, whoosh underneath. That would have been distributed the b to all things, and then distributed the negative 2 to all things in the trinomial. I can do that with this one. I'll show you how that works. Y times y, that's y squared. Y times negative 5, that's negative 5y. 6 times y is a 6y, and 6 times negative 5 is a negative 30. Here are my like terms in the middle. Y squared plus y minus 30. It would have also worked if I had done a table. I'll do y and 6, and y and negative 5. Y times y is y squared. Y times 6 is 6y. Negative 5 times y is negative 5y. And negative 5 times 6 is negative 30. If you notice we have 1, 2, 3, 4 terms to the same 4 terms that we have right here. It's just different ways of getting the same thing. E. I will do the double distributive property again for this one. 2x times 2x is 4x squared. 2x times negative 4 is negative 8x. 4 times 2x is a plus 8x. And 4 times negative 4 is negative 16. These are called additive inverses. They cancel. We're just left with 4x squared minus 16. There is the vertical method also, which I don't traditionally teach students, but since you guys might be interested, here's how it would work. I just put them on top of each other. Negative 4 times 4, negative 16. Negative 4 times 2x, negative 8x. This is sort of like when we do it normally multiplying, and I indent the space and move in a space. 2x times 4, 8x. 2x times 2x is a 4x squared. These cancel, and then you're going to get 4x squared minus 16, which is the same thing as down there. F is one that a lot of students have asked me about. This is not as simple as, oh, I'll just distribute the 2. You can't do that. You could have done that if it was a monomial. Say it was like 6x cubed y squared. If it's a monomial, you can, for lack of a better word, quote unquote, distribute 6 squared x to the 6th y to the 2nd power. But since this is a binomial, 1, 2 terms, you can't do that. You need to write out that it is 2 terms, 2x plus 3 times 2x plus 3. And now there's a binomial, you should realize that it is a whoosh, whoosh. 2x times 2x is 4x squared. 2x times 3 is plus 6x. 3 times 2x is plus 6x again. 3 times 3 is plus 9. Like terms in the middle. 4x squared plus 12x plus 9, which is certainly not the same thing as if you just quote-unquote distributed. More multiplying. I'm going to do the table method. 5x, negative 8. 2x, negative 5. 2x times 5x is 10x squared. 2x times negative 8 is negative 16x. Negative 5 times 5x is negative 25x. Negative 8 times negative 5 is a positive 40. Like terms tend to do the diagonal. 10x squared minus 41x plus 40. Is that trinomial of degree 2. This one I'll do the double distributive property. Whoosh, whoosh. 7w times 11w is 77w squared minus 21w plus 55w minus 15. Like terms in the middle. 77w squared plus 34w. Yep, minus 15. And this last one, I'll go vertical. 7a minus 2, 3a minus 4. Which a lot of students don't do, but I'll show you one more time. Negative 4 times negative 2 is positive 8. Negative 4 times 7a is negative 28a. Done with the 4, I indent the space. 3a times 2 is negative 6a. 3a times 7a is 21a squared. 21a squared minus 34a plus 8 is your trinomial of degree 2. Dividing polynomials, you guys are lucky. You only have to divide by a monomial as opposed to dividing by a binomial, which you used to have to do. All you really have to do is divide each of these terms. If you want me to separate and show you what I'm doing, it's really 30x to the fourth over 6x minus 12x cubed over 6x plus 6x squared over 6. In other words, each term is getting divided by 6x. 30 divided by 6 is 5. X to the fourth over x. There are more x's on top by 3. Minus 12 divided by 6 is 2. There are more x's on top by also 2. 6 divided by 6 is 1. And there are more x's on top by 1. So this is your trinomial of degree 3 that would have given, divided, there's the final quotient. You also could check by taking 6x and multiplying each term by that. And then when you multiply, you should end up with the dividend. B, same thing. We're going to do 3x to the fifth minus 12x squared minus 15x, and then each term gets divided by 3x. So this is 3 divided by 3 is 1. There are more x's on top by 4. Minus 12 divided by 3 is 4. There are more x's on top by 1. 15 divided by 3 is 5, and the x's fully cancel. So this is my trinomial of degree 4. That again is a quotient after I divide this original. You can also check by multiplying 3x by all those, you end up with the same dividend. Last question, number 6, shows a rectangle. Rectangle is important because now we know that both sides are congruent, opposite sides are congruent. The length is 7 more than 5 times its width. So this is my width, it's 7 more than 5 times its width. 7 plus 5x. Right at the perimeter of the shape as an expression. So the perimeter, of course, we know is just add up all the lengths. So it'd be x plus 5x plus 7 plus, don't forget there's another x on this side, and there's another 5x plus 7 on that side. Add my like terms, that's 6x, 7x, 12x, and then 7 and 7 is plus 14, is an expression that represents the perimeter. Now to write the area is just length times width. So it's this times this. In other words, it's x times 5x plus 7. Now if you do that, we know that, area equals length times width. This is my, well, let me reverse them. Width times length. If I do it this way, then you forget it's not x times just 5x. It's x times the entire thing. You have to distribute. So it's 5x squared plus 7x would be a expression that represents the area. That's an equation. Here's an expression, technically. Here's an expression that represents the area. This is a dash